So our next video is going to be on counting, which is probably something you think you're pretty good at, which is fine. Most of you know how to count. But what we're going to do in this video is we're going to talk about how to count um, more complicated things. Things where maybe the numbers get large enough that you don't want to sit down and actually, count on your fingers or something like that. Um, so we're going to talk about some techniques for counting different combinations of things. Okay? So let me give you an example of just kind of the basics of this. So say you have a restaurant, lets you pick one each of 4 appetizers, 3 entrees, and 5 desserts. How many possible meals are there? Okay? So you've got 4 choices of an appetizer, 3 choices of an entree, and 5 choices of dessert. And so if you think about this for a second, how many different possible meals you can make, you'll come across the answer pretty quickly that there are 4 times 3 times 5, 60 different possible meals. Okay? Because once you make one of the 4 choices here, you've still got 3 choices for your next course and 5 choices for your dessert course, right? And so 4 times 3 times 5. This is called the multiplication rule, okay? And so what the multiplication rule says basically is that if you've got different choices, then multiply the number of choices for the first thing times the number of choices for the second thing times the number of choices for the third thing, and so on and so forth, and you'll get the total number of different possibilities. Okay? So I'm not going to write that down, but that's the idea, and that's the principle that we're going to use throughout this entire kind of lesson. And these questions get more complicated, but that's basically going to be the idea. Okay? So the first thing that we're going to think about is when you talk about making choices, kind of the big question that we're looking at in counting is how many ways are there to choose k things from a set of n things. Okay? So this is a little bit different than the problem we were just looking at. But for example, if you were trying to figure out how many 6-letter passwords you can make, you're really looking at the question of how many ways are there to choose 6 letters from a set of 26 letters. Okay? Or if you were looking at choosing groups in a classroom, how many ways are there to pick 3 students from a room of 20 students? So these are the kinds of questions that we're looking at. K here is always the smaller number. It's the number that we're choosing. N is the larger number. It's the number that we're choosing from. Okay, and so N is always going to be larger than K because you can't choose, 5 things from a set of 4. Okay? Actually, that's not entirely true unless you repeat. Okay? So there really are 2 questions here that you need to ask first. So the first question is, can you repeat? Can you choose something more than once? And then the other question is, does order matter? Does it matter what order you choose things in? Okay? And so if you think about those 2 I was just talking about, choosing a 6-letter password Can you repeat? Can you choose a letter more than once? Sure, yeah. Most passwords will let you repeat something. Does order matter? Absolutely, right? The order that you put those letters in the password makes it a different password. So if you had the password AAABBB, which you really shouldn't, that's a terrible password. That's different than the password BBBAAA, which is also a terrible password, right? But those are two different passwords. So order matters and you can repeat, okay? Whereas if you were choosing a group of 3 students from a classroom, can you repeat? If you're picking a group of 3 students, could you say, well, my group is going to be me, me again, and me again? That's not a group of 3 students, right? So in that case, you can't repeat. Does order matter? Does the order that you pick people in matter? Maybe in that situation, right? So if you're thinking about choosing groups, if you're, does it matter which students end up in your group, what order you chose them in? Maybe not, unless somebody's going to get mad at you because you didn't pick them first, right? Something like that. So maybe, okay? So now in the questions that I ask you in the homework and on exams, it's always going to be very specific whether you can repeat or whether order matters because it's going to change the numerical answer. But in real life, sometimes things can be fuzzy. I had a class once where we got into a discussion about whether the order matters that you put toppings on a sandwich. And there was a big debate about whether it mattered if you put the meat first and then the cheese and then the mayonnaise, or whether you could do it in other orders. So again, in real life, this can be a question, and how you count things is going to depend on the answers to these 2 questions. Okay? So we're going to start off with the password example that I just talked about. So I'm going to write this up here. So choose K from N. And this is a situation where you can repeat. Order matters. Okay? So let's look at this example. Choose a 6-letter, let's make it all lowercase, just to make it easier, password. Okay? So we're going to think about that principle, the multiplication principle that we talked about earlier. How many choices do we have for the first letter? Well, 26 choices for the first letter. How many choices do we have for the second letter? Well, 26 still, right? We can repeat letters, so we haven't gotten rid of any. So 26 for the second, 26 for the third, 26 for the fourth, 26 for the fifth, and 26 for the sixth. Okay? So 26 multiplied by itself 6 times, what we would usually write as 26 to the 6th power. Okay? And that's a very large number. Let's see, 26 to the 6th is 308,915,776. So we would have 308,915,776 different 6-letter passwords. Okay? If you look at what we did here, we took the number that we were choosing from, n, and we raised it to the power of the number of items that we had. And this is always going to be true if you're choosing k objects from n. If you can repeat and order matters, you get n raised to the k different choices. Okay? And so if you were, say you wanted to make these numbers and letters, so there were 36 possibilities for each of the 6 letters, you would have 36 to the 6th. So 36 different possibilities for each character, 6 choices, 36 to the 6th. Okay? So if you can repeat and order matters, you're going to get n raised to the k different choices. Now, in the other situations, the math gets a little bit more complicated. So let's look at the next one, what's called the number of permutations. And this is the situation where you can't repeat. But order still matters. Okay? So just kind of building off of that same example, what if you wanted a 6-letter password where you can't repeat letters? Well, what's changed here? Well, if you can't repeat letters, you've got 26 choices still for the first letter, but since the second letter has to be different, you've only got 25 choices for the second letter. Okay? So you could choose, if you chose A for the first letter, and for the second one you can choose any letter other than A. Similarly, for the third, 24, for the fourth, 23, for the fifth, 22, and for the sixth, 21. Okay? So this is called the number of permutations of k objects from a set of n objects. And you can always do it like this. You can say, okay, I'm going to have n choices for the first one, and then subtract one from that, subtract one from that. But it can get very cumbersome if you've got a lot of these different values. You certainly can figure it out this way. There's also a formula for this. So if you can't repeat and order does matter, you can calculate this in one of two ways. So one way is that your calculator probably has a button for it. If you've got a calculator, if you've got a graphing calculator, somewhere, probably in the probability menu, you'll see something that says something like NPK or maybe NPR. And what this means is this is the number of permutations NP of K objects from a set of N objects. Okay? And so if you use this along with the numbers 26 and 6 in this case, so you would say something like 26 NPK 6 and put that into your calculator, it will give you exactly this answer. So 26 it will give you the number, which is 165,765,600. Notice this is smaller than the number where you could repeat because there are more possibilities there. Okay? So that's one way to get this number. Another way is actually a formula for this. So the formula for the number of permutations of K objects from a set of N, so that means choosing K things from a set of N where you can't repeat and order does matter, is going to be N factorial divided by 26, N minus K factorial. Okay, so you probably haven't seen this exclamation point symbol before in mathematics. What this means, N factorial, means to take a number and multiply it by the number 1 less than it, times the number 1 less than it, times the number 1 less than it, all the way down to 1. So like, for example, 5 factorial would be 5 times 4 times 3 times 2 times 1, okay? Which is 120. So 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5, and so on and so forth. And there's also a button for this in your calculator. Again, if you've got a scientific calculator, you'll see it. It'll be like second of something. If you've got a graphing calculator, it's probably under probability as well. Okay? So n factorial divided by n minus k factorial. In this particular case, it would be 26 factorial. That's our n, divided by 26 minus 6. So 20 factorial. And if you plug that into your calculator, you'll get exactly the same thing, 165,765,600. Okay? So our last category, the last thing that we need to talk about is where order doesn't matter. Okay? And so this really doesn't make sense with passwords, so I'm going to kind of abandon that example. But say you want to choose a group of 3 students from a class of 10 students. If you're choosing a group of students, you can't choose the same student more than once. That wouldn't make any sense. And you really, order doesn't matter. It doesn't matter what order you choose them in. It's going to be the same group of students regardless. Okay? So how would we get a number like this? Well, one way to think about it is you can think about choosing a group of 3 students where order does matter, and then saying, well, how many of those groups are the same? And this is the principle. I'm not going to go into how this gets derived. If you're interested, there are other videos where you can watch about that. But this is called the number of combinations. And again, I just say this because it'll help you remember the symbol in your calculator. In your calculator, it's going to be something like NCR or NCK, NCR, NCK, NCR, depending on exactly what they do. But if you do 10 NCR3 in your calculator, it will give you the number of ways of choosing 3 from a group of 10 if order doesn't matter and you can't repeat. And that number is going to be, just to plug this in real quick, 120. Okay? So there is a formula for this, just like there was with the number of permutations. It's going to be n factorial divided by n minus k factorial times k factorial. Okay? So in this particular case, 10 factorial divided by 10 minus 3 factorial times 3 factorial, which will also give you 120. Okay? So if you're trying to count these things, first thing to think about is, does order matter? And can you repeat? Right? So if you can repeat things and order matters, you're going to get n to the k power. If you can't repeat and order matters, you want to use that first formula for the number of permutations. If you can't repeat and order doesn't matter, you're going to use the second formula for the number of combinations, NCR. Okay?